You are welcome to today's lecture on Research Methodology Simplified series. Today we're going to look at lecture 12 titled Sample and Sampling Techniques. Sample and Sampling Techniques. The lecture on sample and sampling techniques focuses on population of the study, sample of the study, rationale for sampling, sampling techniques. Population of the study. Yes, this is what we'll find under chapter 3. Remember, I told you that we don't want to talk much on population and all these things because we're going to meet them in full here. We are here at the proper place right now. So students always find it difficult to define their population. So we're going to make it simplify it here for students to really understand what they mean by population of the study and how to present it. Population simply means a group of people inhabiting a specified geographical location. That is general meaning of a population. Population in educational research include all members or elements such as human beings, animals, trees, objects, events, defined groups to mention but are few. Population defines the limits within which the research findings are applicable or can be generalized. Population is classified into two. We have the target population, we also have the accessible population. Let us look at target population. Target population refers to all members of a specified group. Remember we said what population is. It refers to a specified group in a particular geographical place. So target population refers to all members of a specified group to which the investigation relates. So remember we said population is very, very important in carrying out your investigation. Because whenever you want to carry out investigation, your investigation is going to cover some group of people. It may not be human being, maybe inanimate objects, maybe studying classroom facilities. Like today we had that Ministry of Education and NEC of Nigeria is requesting Nigerian universities to present their readiness and preparedness to resume academic activities. So this is something that has to cover Nigeria. So the population is all Nigerians all universities in Nigeria. So this is the target population. But a person who is trying to embark on this research may not be able or wish to cover all universities. So it has to look for accessible. So example of target population is chemistry teachers in Nigeria. So when you talk about if we want to carry out a research that covers chemistry teachers in Nigeria, that chemistry teachers in Nigeria becomes the target population. We want to study about students, and the students are referring to senior secondary school students, and it's the one that covers the whole Nigeria. It becomes also a target population. Then accessible population. Let us find the difference between target population and accessible population. From the name, it says accessible, the ones you can access. So it's not population is supposed to cover your work that you can access. So accessible population refers to members, elements in the group within the reach of the researcher. So in as much as you want to study all the universities in Nigeria, but during the study you may not be able to reach all the universities in Nigeria. So you may decide to work on the ones that are accessible to you. Maybe you are from Southeast, you decide to work on Southeast universities as where you're going to derive information to talk about what happens in Nigeria. So the ones you can access to you are working on become the accessible. Examples, like remember Mundela say chemistry teachers in Nigeria. But now accessible one is chemistry teachers in Abia State. So these are, you are now studying chemistry teachers in Abia State. You believe that whatever you find out from these Abia State chemistry teachers could be what is applicable in the whole chemistry teachers in Nigeria. They also have senior secondary school students in Akwa Ibom as against senior secondary school students in Nigeria. So that's about accessibility and target. Population can also be classified into finite and infinite populations. This is another where good knowledge of your English will come to help you to understand. You know, when you say something is finite, it's countable. When you say that something is infinite, that means that is not calculation. It cannot count it. It's not countable. Therefore, the things that can constitute your population may be things you cannot count. If you are talking about water, can you count water? If you are talking about things in the bush, can you count them? Grasses, plants, you cannot. But there are things when I'm talking about some level of human beings, like when we talk about vice chancellors, we talk about administrators, talk about principals, talk about students. These ones are finite. So population can also be classified and described as either finite population or infinite population. Finite population have definite numbers of elements or members which are countable. Examples are teachers, chemistry teachers, principals of schools. Infinite populations have infinite numbers of elements and members that is uncountable. Examples are lions in the forest. If you are studying about lions, how can you tell me the number of lions in a forest you want to study? When I want to study in your own forest, in your own community, you can't. So if you want to study about leaves, maybe the venation of leaves in a forest, you cannot count it. Want to study about reagents in the laboratory, it may appear countable, may not appear countable for this one, depending on the where you are, the lab you're working on. We want to talk about chemicals. These are things we see as uncountable. A problem under investigation usually determines the population of a study. Yes, it's when you choose a title. If the title is properly chosen and delineated, you will see the population you want to study there. Conclusions and generalizations are broad view of findings of the study, which must validly apply to the population. Yes, the first thing you have to know whenever you're coming out with your findings, these findings you are getting is meant to cover the population. That's why anytime you're making accessible or whatever, make sure the accessible population are using to carry the work. It's something that whatever you find, they can represent the larger population. Generalization of findings apply more to the accessible population than target population. This is a fact because that's the one you studied. So the information you got is more about that place. For you to use and generalize the target population, you know, it cannot really give you because there could be deviations if you actually should go and study all of them. Population of the study provides the most authentic and reliable data essential for solving the problem. So when researchers specify research population, they set some standard against which the study will be judged. Now we have finished about population. The next thing for us to look at is sample. Sample does not come from the air. Sample comes from the population. So just like when we talk about purpose and objective, when you talk about purpose, you talk about objective. Objective are derived from purpose. Likewise, sample is gotten from the population. Population is a larger space of coverage of whatever you want to study. So if you find out that the population is so large that you cannot cover it, like when we talk about target population, that is so expand, so large, then there's need for you to now go for sampling. Pick a sample. But in picking a sample, there are so many things you have to consider before it becomes a good representation of the population. A sample is a smaller group of elements drawn through a definite procedure from a specified population for inclusion in a study and from which the researcher hopes to gain generalizable knowledge about the whole population. So once you know that the people you are going to study in a group, that whatever information you got from them, you are going to use to generalize the population, you've got to be very careful in choosing your sample. Only elements that make up the sample are actually to be studied. Only elements that make up the sample are actually to be studied. So if you are talking about senior secondary school students in Nigeria, and you now want to study senior secondary school students in Akwa Ibom, so what we are saying here, that only elements that make up the sample, those people you choose from that Akwa Ibom or from Abia State or from the class state you have sampled, are people that are going to study. We will not study other ones you do not sample. Data from the study are collected, generated from the sample studies based on sample data or sample information or sample findings. Sample conclusion or generalization, inferences about the populations are made. A sample should therefore indicate adequate representation of population characteristics to avoid sampling error. What actually do we mean here? If you are studying about students in a larger population and you want to sample, you have to find out what are the characteristics about students you want to study. You will have male and female. These are different characteristics. In this students, you will have people in senior class and lower class of a chemistry. These are things you have to consider. These are characteristics. These chemistry students you are talking about, are they located, some located in rural or urban area? These are characteristics which are going to put into consideration when you are sampling. If you are studying a place and you are located in a rural area and just work with people in a rural area, it cannot be a good representation of the population. If you are living in a city, and because you're living in a city and you're studying about students of a group that should cover both rural and urban, and you use only people in urban area, whatever they're going to come out with cannot be generalized over their study area. So in sampling, you make sure that it's a good representation of whatever characteristics their population covers. Sampling error. Yes, this is a very serious issue that will make you not to generalize whatever findings find out from your sample. And we try as much as we can as researchers and mentors and the supervisors to help students to reduce the sampling error so that whatever findings and results they come out with can be effectively generalized to the population. Failure of any sample to represent the population from which it was drawn leads to sampling error. So if you are studying COVID-19 in Nigeria and you just go to Abuja and pick people and study there, and you say, there's a high cases. Why? When you go to some areas, like maybe you go to Calabar, you say you have fewer, and you don't study, they can't generalize Nigeria, they have. No, you have to study or pick a sample, pick areas, people have low cases, so that whatever result will come out will give us exactly what is the situation in Nigeria. Inferential statistics help to estimate and distribute this sampling error. What are we saying? We know that whenever you are sampling, we are not machine. Even machine makes mistake, even worse. So there are provisions how we can handle this sampling error, make sure it is reduced in your work. When you do your sampling, the type of statistical tool you are going to use to do the analysis of data you collected from the field can help to reduce the sampling error. That's why we recommend to a great extent the use of inferential statistics. We say they go a long way to help to estimate and distribute this sampling error. Inferential statistics also ensure how any difference dictated in a study compares with it. Population characteristics are described as parameters. So whenever you're working with a population, there are some people who use population as their sample because the population where they want to work is not large enough. Therefore, they didn't see any need of sampling. In that case, whenever you're mentioning the characteristics of what you are using there, that characteristic can be described as what? Parameters. Parameters are used to describe the characteristics of a population. Therefore, you can talk about population mean, you can talk about standard deviation, so you can see their symbols. You can talk about correlation coefficient, you can see their symbols. Then when you are talking about sampling, their characteristic is also denoted with something else, not as in population. So anytime you are working with a population, know the right technical language to use to represent them. If you are talking about a population and their characteristics, don't say estimate. You talk about parameters, and their symbols for their mean and deviations are quite different. So now we want to look at sample characteristics. Sample characteristics are described as an estimate against population described as parameter. And this the sample estimate can also be known as a statistic. A sample mean is denoted by this X with a bar on top of the S. The standard deviation is SD. Then we have also the correlation coefficient as we have there. Rationale for sampling. Rationale for sampling are done to, one, ensure that you have a good representation of characteristics in a population you want to study, where you cannot study the whole population. That is the major reason. Whenever you have a large area to cover, maybe you want to study on large and small scale business, and you want to study that in Abia State, in Anambra State, and you want to go just to Onitsha to do that, no, you are bound to have a sampling error. Therefore, you have to make a sampling that will be a good representation of the population. So that's one of the major role of sampling and sampling technique. It also helps to reduce errors. It has so many other work it performs. Sampling techniques. Yes, in sampling, you have to choose techniques, procedure you're going to use. There are so many techniques you can use in sampling, but the one you choose depends on the title of the work and actually what you want to do. If you want to do a shabby work, you can use a very simple sampling technique. If you want to do a good work, you have to find a matching technique that will help you to make a good sampling. A sampling technique is a plan specifying how elements in a population will be drawn from the population. So when you have a population you want to study and it's so large, you cannot cover them and you want to sample, you have to know how to pick representation of the population so that it will be a good representation. So if you are doing this, that's what we mean by sampling. So method used in sampling it is what we call sampling technique. Sampling techniques are categorized into two major types. We have the probability sampling techniques and we have the non-probability sampling techniques. So whenever you want to sample, you may decide to go with the probability sampling techniques or non-probability sampling techniques. Naturally, in a science or in a scientific research, we know that once you apply probability sampling techniques, you are using the best. It's the most standard. It will give you a good sampling. To produce a good sample, it will reduce error. But some other cases, there are times you may not be able to apply probability sampling techniques due to circumstances. In that case, you have to apply a non-probability sampling technique. You're still going to get a good result, but the generalization cannot be as good as when you use probability sampling techniques. Let us look at probability sampling techniques. There are so many of them. One of them, the most common and the simplest and the best, is that simple random sampling technique. Simple random sampling technique. This is the #1 probability sampling technique recommended all over. And that is the best that can reduce sampling error. That is one that can give you a good representation. And that one, the one that will remove any form of bias in your sampling. Because in consequent random sampling, you do not have any person in mind. You do not want to work with any person. It's any person that's chosen by his own fate that will be studied. Another sampling technique is the one we call complex random sampling. This is complex random sampling. I think we're going to discuss this in detail. We also have systematic sampling. We also have stratified sampling technique. We also have the one cluster sampling technique. Let us look at the simple random sampling technique. Simple random sampling technique is a process of sampling that allows individual elements of a given population independent and equal chance of being selected into the sample. Yes, that's why I say it's the best. You want to pick the schools you want to study, or you want to pick university to study when you want to study something that happens in Nigeria. The first thing you do is to go and look about which states will you cover, so it will be a representation of Nigerian universities. You may decide, because we have 36 or 37 states, you may think you want to work with about 50% of the states, which is about 18 states. So which 18 states am I going to work with? You can use simple random sampling instead to pick it. So you don't go and bias because you are living in the southeast or because you are living in northeast. You work with more of university in the northeast. What you just need to do is to write the names of these 36 states in Nigeria out. Give them number, then write their numbers in a piece of paper, then put them somewhere, dip your hand and pick until you get up to the number you wish to have. So out of this, I think you dip your hand 18 times, you get the number of states you want to work without bias. So a simple random sampling is a process of sampling that allows individual elements. So once they are there, any state is there, so that you choose any state to work with. It's not because you like it or because you don't like it. The choice is independent and equal chances is being given in selecting that one. And it reduces greatly the probability of choosing a biased sample. Processes are by balloting. In balloting, like I've described before, you have to get the element and number, give them number. As you give them number, if by balloting, that means you have to do what? Write down these numbers in a piece of paper, put it in a box or in a bag, then shovel them very well, then start dipping to get the number you want to study out of the whole population. And by studying is by balloting. Some can say by tossing of coins. That means that is workable when you have fewer population you want to choose from. So you say if you choose this, you give the number out of, like a Ludo, the seed has 1 to 6. So you say if you toss and anyone that is up, number 5, the one that is number 5. You toss again. If you get number 2, you pick another number 2. By so doing, you do simple random sampling without any bias in it. We have a systematic sampling as another probability sampling technique. In systematic sampling technique, say it is a modified simple random sampling technique. It's a modified one. Elements are drawn at a specified interval from lists containing all the elements in the population. Samples selected in a systematic manner involves some restriction. Random order is preferred in the randomization. So in the systematic random sampling technique, this is a place where you have a lot of population members, group elements are many. So you can give them a number, a random number. A random number is number, it's not what you say 1, 2, so that number can vary, can mix up. The number 20 can come first, number this can come first, they will mix up. So this is a simple random sampling, systematic sampling. Then you decide that you are starting now. Every 5 you pick, every 5 you pick. So you, by so doing, you do not know, but all you know that once you pick any number 10, you go and know from the list you have which state or university or element represent that 10. You pick it. You go and next 5, you know maybe next 5 is 15 or 16, you go and pick. By so doing, you are doing systematic sampling. Look at the example of a systematic sampling. I say examples of code names of members. So somebody in a group, you have 001, 002, 03, 04, 05, 06, 07, 08, 09, and 010. So in this case, as much as you have 10 members from which you want to sample, and you have given the code numbers like this. When you are given the code number, you just have a list somewhere. You may say in every 2, count 1, 2, you pick, 1, 2, you pick. So, and look at the underlines from this first 10. Number 2 is the second, number 4, number 6, number this. Then you go back to where you have the names and number and know which of these items represent this underline, and they become the ones you're going to study. If you have up to, okay, if you want to, like I say, randomize number, in a way you randomize this number, can you see what starts is no longer 001, it's 004. So this is preferred, so that if you put 1, maybe you love number 1, you can say I'm starting from 1 or 1 number 2. So you want to shuffle like this, then it's more free from any bias. So because you say every 2 you take, you now say move. So 001 that was not choosing was choosing here. Move again 006. You see that numbers you choose may vary again. So essence of this is to reduce what bias. The same thing happens here. Here I decide that you are moving in every 3 because the number of elements are many. So you can increase how you want to choose. So every 3 you choose every 3. Here you can turn and say I'm starting from the first one to choose before moving in 3s. So same thing. So admission list, ledger, examination list, classroom sitting arrangement can be done using this method. Stratified sampling technique is another probability sampling method we want to look at. Stratified sampling involves categorization of populations into homogeneous subgroups based on already identified parameters or variables. So when you want to stratify a sampling, you will stratify a sampling not based on the existing. It is you that will look at the population and see the characteristics that's there, and based on the characteristics stratify them. Maybe you are studying teachers. If you are studying teachers, you may find out that the first characteristic you see there that you have male and female. So you can stratify them into male and female. You may find out that these teachers are located in different locations or school types. In those located in a co-educational school, mixed school, or boys or girls, or rural and urban. These are the conditions you can start and can stratify. We say again, can stratify based on religion. You say Christians and Muslims. You can talk about, we are working on secondary schools. You can stratify them based on JSS and senior secondary school. In color, you can talk about red, blue color depending on what you are studying. You can talk about qualifications, which means you can stratify them based on qualification, PhD, Masters, HND, what have you. Then subjects, classes, educational level. Let us go to cluster sampling technique. Cluster sampling technique applies to large population widely distributed over a geographical area. A division of large population into distinct units, sections known as clusters. These clusters are exhaustive and mutually exclusive. Sample random sampling is then applied to draw the members. So what are we talking about? A cluster sampling. We are talking about a stage whereby you want to work with a student, but this student you want to work is staying within a particular state. If I use Anambra as a typical state you want to work and pick this student, you find that in Anambra State you have different schools are located in zones, and we have about 6 zones in Anambra State. In Anambra State you have about 3 zones. So when you come to the zone, you have this cluster. These zones becomes clusters. You want to look at what's happening in these 6 clusters. When you come to the zones again, you have local governments. They can serve as also clusters. So you look at what is already existing in large population, break it and use those things as their cluster. We also have what we call multi-phase or multi-stage sampling approach. We don't always argue. Some always say multi-stage sampling technique. Say it's not a technique. But what multi-stage phase or multi-stage approach means that whenever you want to do your sample, you do not go straight to that people want to work and sample them. That you have to pass through stages. Like instance, what I've explained before. You want to work with students, but these students are located in Nigeria, first of all, or located in in Nigeria. In Nigeria, we have 6 geopolitical zones. So you don't want to work all the 6. It's cumbersome. You decide to work with 2. So the first stage sampling is to choose which state are you going to work with. So you have to sample the state, or now you have to sample the geopolitical zone. Maybe say southeast and south-south. So these are being the first stage you're working. When you get to this geopolitical zone now, you say there are states in them. In southeast geopolitical zone, you have 5 states there. You may decide to work with only 2 or 3 states there. You do another sampling there at the second stage. Then when you get to the state you want to work, there could be education zones. You get there. If you leave the education zone, you get to local government. If you go to local government, then you get to the school. When you get to the school, you look for students there. So you are moving stage by stage before you can reach to the actual element or actual participants in this. So single stage or phase sampling refers to cluster sampling or sequential sampling. Examples, I say Nigerian parents, Nigerian dressing, instance of secret course in universities. So the first sampling, you come to Nigeria, first stage. You say, can I work with every Nigerian parents in Nigeria? No. You break it into geopolitical zones. Say I have 6. So you know how many. Can you study all? No. You start to select using simple random sampling to pick about 3 or 2 or 4, depending on the number you want to study. Then from that, the one you study, you know if you are talking about Nigerian to states, you can jump the geographical zone and say, in Nigeria, I want to look at it as a nation that has 36 states. So how many do you want to study? You sample the number you want to study. Then if it is geographical state you use southeast, that means southeast has 6 or 5 states. From there you choose. Then from the state you move to local government. You also sample, and so on and so forth. Let us look at non-probability sampling techniques. I say they are also good methods of sampling, but not as good as probability sampling technique. Non-probability sampling techniques, they refer to a situation where population elements have no equal chances of being selected. So in non-probability sampling, unlike in the other one where every member has a chance of being selected as their heir, they don't know the one, they don't know. But in this case, they don't have equal chances. That's why it's do connection. That's why it's this the one preference. You can make a preference. You are biased. You can choose the ones that are very close unconsciously. So there's no randomization. Why randomization is the beauty of a probability randomization, a simple random technique. You have to randomize in picking. But this one, no randomization. Examples of non-probability sampling techniques are purposive or judgmental sampling, convenient or accidental sampling, quota sampling, like you say, purposive. So you have to judge by yourself. I think this group will be okay for this study I want to carry out. So judgmental or some quite purposive. Convenient, as you are moving, any person in your job, you want to work with teachers, secondary school teachers. So any place you meet a secondary school teacher, please help me do this, be part of my study. That is by convenience. Quota sampling. We also have, let us look in detail about purposive and judgmental sampling. Purposive sampling is the process of selecting specific elements which satisfies some predetermined criteria. Criteria is based on the researcher's judgment. I'm talking about the criteria are based on the researcher's judgment. So it is you. You want to study about traditional chief. You say, well, I don't want to sample because I'm working on traditional chief. They will serve the purpose. You have joined and you study those. Example, leadership styles of traditional rulers with 5 years experience. So already you say, I'm working with 5 years experience traditional rulers. You have decided on people want to work. So you don't need to go and do all this rigorous sampling. You move straight to this group. Mathematics teachers with 5 years post-qualification experience. You've already judge what you want to work on. Similar to quota sampling, but ensures better representation of elements. Quota sampling. Quota sampling is the process of selecting accessible elements having peculiar and particular characteristics of interest to the researcher. It is a probability equivalent of stratify, ensuring that various subgroups of target population are duly represented in the sample. Example, selecting qualified students for university admission reflects categories in a population. So when we're talking about quota sampling, like I'm using a case of instance of admissions of students, you know that there are people that come from different groups when they're seeking for admission. There are people who are living at that university, but they may have no voice. There are people who have names, like they have the vice chancellor, have the key officer in the university. They have their people of interest they want to favor to give admission. There are people at the high level, like if in Nigeria, I would say people at Abuja, the politicians that detect what happens. They have their own list. We may say, okay, there are people that are always backward, like when we see the northerners, that their scores, JAMB is always very low. If you should use only JAMB score, mention that cutoff is this, then some of those people will be cut off. So that's how come with the quota sampling system, why it is very, very relevant. So if you want to make sure that every category is captured, you have to apply this quota sampling so that when you come and say merit, people who are highly intelligent, let us give them some quota. People who are living around the university, let us give them some quota. Okay, the key officers at the university, they work hard there, we should give them some preference. Let them give them some percentage and things like that. This is what we mean by quota system. So quota sampling is the process of selecting accessible elements having particular characteristics of interest to the researcher. It is a probability equivalent of stratify, ensuring that various subgroups of target population are duly represented in the sample. Example, as I've said before, is when you are selecting qualified students for admission or university admission, you must have to reflect categories in a population. We also have dimensional sampling technique. This is the extension of quota sampling. You already understand what I mean by quota sampling. It involves specifying certain relevant factors, characteristics of interest, which are dimensions of the population. Examples are gender, ethnic group, religions, affiliations, level of education. So already in the quota, as we say, it's related to quoting center. So when you have these quotas, remember in that group, when you say most educated or very intelligent one, or say this is quota, or say catchment area, remember there are other sub-characteristics there. You have male. Don't make sure that when you are practicing quota, that it favors only the female or only the male. Don't ensure that it does not only favor only one denomination in the church, like the Catholics, the Anglicans, the Pentecostal, and things like that. Or ethnic group, people who are maybe outsiders or this particular ethnic group. Affiliation, level of education, maybe only their light. So this dimensional sampling added to quota sampling will make sure you have a good representation. Then we have the one we call snowball sampling. It's another unique one that people rarely apply. But there are kind of study you want to do, you must have to apply snowball. If not, your sampling will be poor and have a plenty sampling error. Snowball sampling applies to situations where an initial small sample is employed to generate more sample elements who possess the same characteristics as themselves. Members of these populations are hidden in sense that their members are not easily identifiable. Snowball sampling is also applied in the meta-analytical studies to identify articles for inclusion in the analysis. Snowball sampling is time and money conserving. It is appropriate in dealing with difficult or hidden populations whose elements may not be known or accessible to the researcher. So when I'm talking about snowball sampling, people were wondering because it's not a common sampling method or the word look strange and foreign. In snowball sampling technique, as I've already illustrated here, you want to study about students' characteristics and behavior in university. So when you're sampling, when you talk about students, there are group in the universities, group of students in university that you may not pick people from or study them as a group because they are hidden in a bigger population. We talk about secret cults in universities. Members of cults, it's inevitable they are there. So if you want to study about student behavior or how to improve student behavior, and you do not remember this, and go and find a way of picking people that represent that cause in university. There are people who are prostituting in university, and you want to talk about study about students how to improve their behavior. You do forget that there are people who are working as commercial sex workers. There are cocaine pushers. There are bandits, and so many people. These are smaller groups are hidden in a population. So you just look at students at their departments and this without going to look at this. That's the sense of snowball sampling.